All right, let's talk about one of the biggest, most frustrating problems in AI today. Its tendency to just make things up. These aren't just simple mistakes, they're what we call hallucinations, and they are a massive hurdle in the race to build AI that we can actually rely on. Let's dive in.
So let's just start with a number, 27%. Some studies are showing that's how often a chatbot might give you a wrong answer. Think about that for a second. Almost a third of the answers you could get might sound incredibly confident, but be completely and utterly false. That is the scale of the problem we're dealing with.
So, what exactly are these plausible lies that AI keeps telling us? Let's get a clear definition. You know, an AI hallucination isn't just a simple bug you can patch. It's when an AI generates an answer that seems totally believable, totally reasonable, but it's factually wrong or just invented out of thin air. This is kind of a side effect of how these large language models are built. See, they're optimized to be fluent and conversational, and sometimes that comes at the cost of the truth.
So why is this such a huge deal? Well, the stakes are incredibly high, and it goes way beyond just losing trust. I mean, think about the real-world impact. We've literally seen a lawyer get into serious trouble with a judge because he used an AI that just made up fake legal cases for his brief. That's massive legal exposure. And for businesses, if your employees have to go back and manually fact-check everything the AI says, you've completely wiped out any efficiency gains you were hoping for. This is a problem that hits everyone, from you and me all the way up to the C-suite.
And you bet there's a price tag. One estimate suggests that a single major hallucination incident can cost a company as much as $2.4 million. This is not a theoretical problem, it's a very, very expensive one.
Now, with a problem this big and this costly, it's really no surprise that a whole industry has sprung up to try and fix it. The first wave of solutions are what I like to call the hallucination detectives. These are tools that investigate the AI's claims after the fact.
And here's just a quick look at the landscape of these so-called detective tools. You've got a whole spectrum. So, for example, a massive company building a sophisticated AI agent might use something like Maximi to run thousands of simulations to try and break it before it talks to a single customer. On the other end, you've got open source tools like LangFuse, which are perfect for a hands-on tech team that wants to trace every single thought process of the AI to see where things went wrong. But the key thing to remember is that all of these tools are basically external fact-checkers. They work from the outside in.
But this whole detective approach is reactive, right? It's about catching the lies after they've already been told, which leads to a much more interesting and much more powerful question. What if an AI could learn to fix its own mistakes?
And this brings us to a really revolutionary idea, AI's self-correction. Instead of just building better detectors, what if we could build the ability to find and fix errors directly into the AI model itself?
As these researchers point out, this is something current models are, and I quote, severely lacking. It turns out you can't just tell an AI, hey, that was wrong, try again, and expect a better answer. It's become really clear that we need a brand new way of training these things.
So why is this so hard? Well, it really boils down to two major problems. The first is something called distribution shift. This is where the AI gets really good at fixing the mistakes of an old model, but it's completely blind to its own new mistakes. The second, and this one's a bit funny, is behavior collapse. This is where the AI basically gets lazy. It just learns to repeat its first guess with a few words changed, never actually rethinking the problem from the ground up.
So, to get around these roadblocks, researchers at Google DeepMind have developed a brand new method called SCORE that stands for self-correction via reinforcement learning. And believe me, this is a genuine breakthrough. The best way to understand SCORE is with this analogy. The old way of training was like giving the AI an answer key for a test. Sure, it can memorize the right answers, but it never learned the process of how to find its own mistakes. SCORE, on the other hand, is like actually teaching the AI how to study. It doesn't just get rewarded for the final answer, it gets rewarded for the process of improving itself. It learns the actual skill of self-correction.
So how does it actually work? Well, it's this really clever two-stage process. In the first stage, it decouples the first attempt from the second attempt. This is the secret sauce that prevents that behavior collapse. It stops the AI from getting lazy. Then, in stage 2, it specifically rewards the AI for making progress. The reward isn't just for getting the right answer in the end, it's for the measurable improvement between attempt 1 and attempt 2.
And the results? Well, they're pretty incredible. On a really tough math dataset, a standard model could self-correct about 41% of the time. The model trained with SCORE, it jumped to over 64%. That is a massive leap in performance. It proves that teaching an AI to think critically about its own work isn't just possible, it's incredibly effective.
Okay, so what does this all mean for the future?
It really feels like we're watching two different but equally important paths emerge in this race to build AI we can actually trust.
On the one hand, you have the external detection path. That's the whole ecosystem of detective tools we talked about, acting like diligent editors that fact-check everything after it's written. And on the other hand, you have this new path of internal self-correction, the idea of building critical thinking right into the AI itself, teaching the writer to be their own editor. One is about catching mistakes, the other is about preventing them in the first place.
And that leaves us with the big question. Which path is going to get us there? Will the future of trustworthy AI rely on a world of powerful external fact-checkers? Or will it be a world of AI models that have finally learned to correct themselves? The race is on, and honestly, the outcome is going to define the next era of artificial intelligence. Thanks for tuning in.